Hello everyone. Today we are starting our unit 5, and this unit has two major topics to cover. The first one is hidden line surfaces. Okay, so half of the unit covers this topic, and the rest of the unit covers this topic, elementary model. Okay, so we will first cover the first half, that is hidden lines and surfaces. Okay, what do we need to study about this topic according to the examination are the following algorithms. Okay, so for hidden lines and surfaces, there are few algorithms that works to serve this purpose. Okay, so they have to study all these four algorithms one by one. So we'll cover those. Uh, okay, so we'll start with the topic. The name is hidden surface removal, or the topic was hidden lines and surfaces. So the basic concept is known as hidden surface removal. Okay, and this is also known as visible surface detection in few books, or backface removal, or backface culling. So these all terms represent the same concept, that is hidden surface removal. So we'll discuss about that. What is the meaning of visible surface detection or hidden surface removal? The most commonly used names are either visible surface detection and hidden surface removal, and you can see the contrast between the name. That hidden surface removal, what the name suggests, that the surfaces that are hidden should be removed. Okay, and the opposite would be the surfaces that are visible should be detected and displayed. Okay, so either way we are doing the same thing. Okay, and the name is backface removal. So backface removal means according to the viewpoint, whatever lies in the back side would not be visible, and hence those parts should be removed, as the name is backface removal and or backface culling. So these are the names for the concept that is we call as visible surface detection or hidden surface removal. Now, why do we need this topic? Okay, first we will understand that. So before moving to the algorithm part, we must understand that what is the need of these algorithm, what is the need of this concept, why do we need to find the hidden surfaces, why do we need to remove them. Okay, so basically uh, what happens is, in real life, the opaque material of solid object obstruct the light rays from hidden parts and prevent us from seeing them. Okay, so in real life also, uh, in a particular scenario, if they are placed so many solid objects, okay, so the solid objects obstruct the objects that are placed beside them. Okay, so you can only uh, see those objects that are not hidden by those opaque objects. Okay, this is what called realism. Okay, because we are talking about the real life, that's how we perceive the world. Now to achieve this in computer graphics, what we do, because in computer graphics, this is not an automatic process. Okay, this is now the this is not how the images are rendered. Okay, so we have to achieve that realism. So in the computer generation, no such automatic elimination takes place when objects are projected onto the screen coordinate system. When we project a particular scene over the screen, the computer graphics doesn't have an automatic method to sense those objects that are hidden by the objects in front of them, solid objects in front of them. So we have to create a concept, or we have to apply some method so that the scene is rendered exactly what we experience in real life. Okay. Instead, all parts of every object in computer generation, we are talking about in computer graphics, all parts of every object, including many parts that should be invisible, are displayed. Because what happens is, uh, if we talk about computer generation, that means if we create a scene using computer, we know that if the scene is made up of so many objects, like 5 or 6 objects, these objects are modeled in a different coordinate system, that is modeling coordinate system. And we place these objects in such manner that they create a world on a scene. So computer graphics doesn't have a method to understand this thing, that the solid object obscure the vision of the objects that are placed behind them. Okay, so there is no such method in computer graphics. So we have to apply some logic to represent or to render a scene in such a way that looks similar to the real life. Okay, the effect should be like a real life. To remove these parts and to create a more realistic image, we must apply a hidden line or hidden surface algorithm to set of objects. Okay, so inside a scene, if there are a set of objects, we can apply hidden line or hidden surfaces. Why we are using the term line or surfaces, we will understand this thing in a moment. Okay, where we will see the approaches to implement uh, hidden surface removal concept. Okay, so see, what I'm talking about is, uh, let's suppose you are asked to draw a 3D object. Okay, you are asked to draw a 3D object using computer. So in computer, you generate a cube like this. Okay, so a cube would be created like this. The cube will have 6 faces of equal length, and it will look like this, है ना? But in real life, if you see an cubic shape like this from a certain point, let's suppose from front, you are as an observer, you are facing this object from here, from the front. This object should look like this, not like this, but like this. That means these portion, this entire back face, okay, and this particular portion and this particular portion must be hidden, okay, because we can't see them. So it should be rendered like this if it is viewed from front, and it depends upon the viewing position of the observer. Okay, if the same cube is seen from the top, you would be able to see only the top face. Okay, so in that case, rest of the sides uh, should be invisible. Okay, so the idea is, out of 6 sides of the cube, which side should be visible to the viewer depends upon the viewing position. The idea is, out of 6 sides, the idea here is that out of 6 sides, which side should be visible will be depending upon the viewing position of the observer, since rendering an image requires complex computation. See, because this cube, we in frame buffer, we will have the information about every side of this cube. But to render or to represent this entire image, like that means to fetch it from the frame buffer and to display it on some random graphic system or raster graphic system, will consume CPU cycles. Okay, so it's a expensive affair. It requires a lot of computations. It requires a lot of CPU cycle. So if we are not going to be able to see those faces of those part of the object, that should be obstructed. So why should we render those objects? Why should we render those part of an object? That is the whole idea. Okay. So this is written here. Since rendering an image requires complex computation, we do not want to compute those parts that are not going to be visible on the screen. If it is not going to be visible on the screen, why we have to go through all these computations, or why we have to waste our time to render those parts that are not actually going to be visible. So there is no point to draw this back face or this side face, okay, because it will not look realistic. Okay, or a 3D object should be represented as a realistic image on the screen. Okay, so this is not realistic, this is realistic. And remember one thing, that this is required only in case of non-transparent objects. Okay, so this cube has to be a solid, or we can say that an opaque object. Okay, it should not be a transparent object, because in the case of transparent you will be able to see all these faces. Okay, so this is one condition, that for the opaque objects we are dealing with this problem. Okay, now look here, see, this is there are two scenes. Basically this is one scene, and if you render it using without eliminating the hidden surfaces, okay, so what will happen, that see this table, and somebody is looking this scene from here, so this particular portion should not be visible. Okay, and this particular portion should not be visible. Okay, because this is obscured using this particular object. Okay, so this is the wrong visibility of the scene, wrong rendering of the scene, and it is not required. It has used more computation and the time. Okay, while this is the correct visibility, you can see here this particular portion has been hidden. Okay, and this particular portion has been hidden here. So that is the problem with hidden surface removal. Okay, and to achieve the realism, to achieve the realistic view, we want to detect only those surfaces that are visible from a particular point, particular viewpoint, and out of the entire information that is stored in the frame buffer for that particular scene, we would want to fetch only those information that is necessary to render the visible portion of that particular image. Okay, so why do we need it? The goal is to detect the visible surfaces, or to detect the hidden surfaces and remove them. To either detect the visible surfaces, okay, and display them, or detect the hidden surfaces and remove them. Why do we need it? I have already told you. Just go through these lines. Drawing polygon faces on a screen consumes CPU cycle. Mostly an object is composed of the polygon. Okay, so drawing these polygon faces on a screen consumes CPU cycles. We cannot see every surface in the scene, because just imagine a complex scene. We are not talking about 2 or 3 objects. An entire live scene, lively scene. If you imagine a particular scene, it may include hundreds of objects, and you cannot see every surface, not every object. I'm talking about every surface. That means an object is composed of many surfaces, and few of their surface, or half of its surface, may be hidden by uh, some other object. So we cannot see every surface in the scene. So in order to save the time and computation, we draw only those parts which are visible. That is why we need hidden surface removal algorithm. So applying this concept, we have seen we are going to study four algorithm. Okay, backface detection, depth buffer algorithm, a buffer algorithm, and scanline algorithm. But all these algorithms are based on two approaches. That means there are two approaches for hidden surface detection or visible surface detection. And in these two methods, all those four algorithms uses these two methods. Okay? So they either fall in the category of object space method or image space. Okay, so I'll read it for you. Object space method. In this method, various part of objects are compared. After comparison, visible, invisible, or hardly visible surfaces determined. These methods generally decide visible surfaces. In the wireframe model, these are used to determine a visible line. So these algorithms are line-based instead of surface-based. See, ये क्या कह रहा है आपका कि in this method various parts of objects are compared. See, look at this scene. There are three objects. Okay, this object and this object, this particular triangle and this sphere and this cube. So these has been designed in a model coordinate system. They have their own coordinate system. While we talk about object space method, first thing is we deal with a physical coordinate system. Physical coordinate system like our actual XYZ coordinate system. Okay. So this definition is saying that various parts of objects are compared. Various parts of objects are compared. That means this triangle would be compared with this sphere and against this cube. Okay, so here you can see that this particular portion and this particular portion of this entire cube, these particular portion including the back faces or the top face of the cube, these surfaces are also obscured, okay, obstructed by these two objects, okay, and this particular triangle is hiding this particular portion of this square. So all these surfaces or all these polygons are compared with each other, or part of these polygons are compared with other parts of the different objects in order to find the visible portions. Okay, after comparison, visible, invisible, or hardly visible surfaces. These methods generally decide visible surfaces. In the wireframe model, these are used to determine a visible line. If you remember, in the very first line, I have shown you the wireframe model of a ship or an aircraft. Okay, so there also there we do not deal with the surfaces, we deal with the lines. Okay, so which line is visible and which line is not visible in the wireframe model that we see in object space method. Okay, so these algorithms are line based instead of surface based. So we do not consider the entire surface, but we consider lines here. Image space method, here positions of various pixels are determined. Basically, image space method deals with the screen coordinate. Object space method deals with the works in the physical coordinate system, that is our world coordinate system. बताया था मैंने आपको 3D viewing pipeline में. Okay, so basically this algorithm is applied to the actual vertices before converting those vertices into the screen coordinate. Okay, and image space methods are applied to the screen coordinates. Okay, so that is the basic difference. It is used to locate the visible surface instead of a visible line. Here we deal with the lines, here we deal with the surfaces, and it compares part of the object. It deals, it basically works pixel by pixel. So we see visibility of every pixel Okay, we scan the algorithm pixel by pixel, and whatever pixel is visible, that would be on or that would be displayed. Okay, if a point is visible, then the pixel is on, otherwise off. It would be more clear when we will study the example of these two algorithms. You by knowing the working of those algorithms, you will get a clear idea of these two methods. So in your examination, you would be asked to write the differences between these two methods. So I have mentioned few differences between object space method and image space method. First, it deals with object definition directly. You can add more point that it works with the physical coordinate system. Okay, so the meaning is same. It deals with the object definition directly. That means before converting to the screen coordinate, we apply the hidden surface algorithm to the actual physical coordinates. It compares the objects and parts of objects to each other within the scene definition to determine which surface as a whole labeled as visible. So I have shown you the example that we compare here all the object in the scenes with each other in order to determine which part is visible and which part is hidden. Okay, initiated for random graphic system. This method is not very famous. Uh, in computer graphics, this method is not mostly used. It is initiated for random graphic system. So we know that most of the graphics display doesn't work on random graphic system or vector graphic system. So it has very limited use. It is used for accuracy. Whatever algorithm we use for uh, visible surface detection using object space approach has better accuracy but limited application. One such example of an algorithm that uses object space method is backtest detection, a very important algorithm from the exam perspective. Next is image space method. So it deals with the projected images of the object. That means it works with the screen coordinate. So we first project the image, and after that we apply the hidden surface removal algorithm. We apply the hidden surface removal algorithm to the screen coordinate. That is the basic difference between image space and object space. In this method, visibility is decided point by point at each pixel position on the projection plane. So what we do, we will scan the entire projection plane. We will examine every pixel and we will see according to the algorithm which pixel is visible and which pixel should not be displayed. Initiated for raster scan system. It was initiated for raster scan system. Mostly we use image space method. This is more famous than object space method. It is used for time saving operation. So while the object space method algorithm provides accuracy, image space methods are used for faster operations. And one example for image space method is depth buffer method, also known as Z buffer method or Z buffer method. Again, very important from the exam point of view. And these are the characteristics of approaches. Basically, we have seen two approaches to apply the concept of hidden surface removal. Now, out of object space method or image space method, which approach should be used depends upon these four characteristics, or we can say that four questions that need to be asked before using either of these approaches. First one is memory requirement. That means in which approach we require larger memory. Okay, so memory is a concern here. If an approach requires larger memory, so can we implement that? That is the question. Second, processing time. Which algorithm takes lesser time or has convenient processing time, that we must take into the consideration type of type of object. Either we are dealing with a solid object or we are dealing with a transparent object. So we have to see that also. There are algorithms for transparent objects also. So whether we should use object space method or whether we should use image space method, that depends upon the type of object. Are you dealing with the solid objects? Are you dealing with the opaque objects or transparent objects? So there are few algorithms that also work for the transparent objects. Complexity of scene, that is also a factor to consider it, that how complex your scene is. Okay, if there are too few objects, so which approach uh, will require? Okay, do you want accuracy or do you want faster computation? These are the factors that needs to be considered before choosing the algorithm. Either we are going to use backface detection or image space detection or A buffer, Z buffers, inline algorithm. That depends on all these characteristics. So hope this is the basic introduction for the concept that we are going to study in next few days. Okay, thank you so much.